In this lesson, we're going to examine an idea we can use for non-right triangles. SOHCAHTOA is great, Pythagoras is great, but they're limited to right triangles. Okay. When we have non-right, we need new tools, and we're going to develop one of them today. So the first one is the sine law. The way the sine law works is it examines the relationship between a side and the angle across from it. So if we take a look at this diagram right here, this triangle, first thing I want to point out, capital letters are always used for angles. The small letter that's across from it is always the corresponding side. So big A and little a are always across from each other. Big B is angle B, small b is across from it. That's side B. Big C, small c. Okay. And the relationship that exists is the sine law here. The sine of your angle divided by your side is always consistent. So if I know big A and little a, I can find either big B or little b by cross multiplying. Now the good news is there's only two problems you have to worry about, a missing side or a missing angle. The bad news is they take a little bit more work than SOHCAHTOA. So let's take a look at the two examples. I want to solve the triangle. That means all missing pieces. So all the missing angles, all the missing sides. So the first thing you do is going to label it. Big X should be across from little x. Big Z should be across from little z. Okay. I look at this triangle and I say to myself, I know two angles. I can always get a third angle inside a triangle. This triangle's add up to 180. So I can find big Z, the missing angle, by taking 180 minus 70 minus 50, and I'll give my angle right here, which is 60 degrees. So I've already got a missing angle. All I need now is the missing sides. To do this, I have to use the sine law. I have to use the sine law because it's not right angled. So I'm going to match up things that go together. I know this side and this angle are across from each other. So I can say the sine of 70 has to go with 17. Make sure this is your angle and this is your side. And then I'm going to match up the next pair of things that go together. Let's do the x first. So I know these two things go together. So the sine of 50 goes with x. There's my problem to solve. I'm missing a side. To do this, I'm going to cross multiply. I'm just going to erase that part, make it a little bit easier to see. So let's cross multiply. X times sine 70. Well, that's x sine 70. 17 times sine 50. 17 sine 50. I want to get x by itself. So 17 sine 50 divided by sine 70. I'm going to put that all into my calculator just the way it looks. So you're going to have to use sine twice here, top and bottom. Be a little bit careful. And I got 13.9. So hopefully you guys get the same thing. There's my missing side. Now on to the next one. I want to find side Z. I want to do that. I'm going to do the same problem again. I can still match up 17 with 70. That hasn't changed. But to do Z, I have to match it up with the 60. So sine 60 going with Z. It's the same kind of problem we just did to find x. So we're going to cross multiply. So Z sine 70 equals 17 sine 60. We're going to divide it out, same way we did before. Put it all into our calculator, and hopefully for Z you should get 15.7. And that's problem number one, finding missing sides. We did it twice just to get a little bit of practice. But that's our first missing problem. Okay, let's try the next one. Again, we're still solving the triangle, so I want to find the missing parts and pieces. I look at this and say it's not right angled. I can't use SOHCAHTOA, but I can match things up. Side M goes with big M. So the first thing I can write down is the sine of my angle and its corresponding side. Next, what else do I know? Well, I know 37 is going to go with L, but I'm missing the angle. So this is problem number 2, a missing angle. So to do these ones, again, we're going to cross multiply. But we're going to be a little bit trickier this time. So 37 times the sine of 32. Well, that's 37 sine 32. But instead of multiplying the 43 with the sine L, I'm just going to leave it where it is. The reason I want to do that is now I kind of have L by itself. I have the sine of L by itself at least. To find angles, missing angles, I'm hoping you remember that to find them, we have to use inverses. So I'm going to take the inverse of whatever all this big mess of numbers happens to come out to. And if you do it right, making sure you're using your inverse button, keeping all your decimals as much as you possibly can, you should get 27.1 degrees. Okay. Back to our diagram for a second here. Now that I know that L is 27.1, I can figure out K. I can figure out K because triangles add up to 180. So, if I want to figure out this one, I can do 180 minus 32 minus 27.1. And obviously this is not to scale because I get a K value of 120.9. That's okay, don't assume diagrams are to scale. And now I can solve for little k. How am I going to do that? Which things match up? Well, 32 and 43 still together. So sine 32 goes with 43. And the sine of 120.9 goes with k. So this is back to problem number 1, a missing side. How do we do those? We cross multiply and solve. So k sine 32 equals 43 sine 120.9. And I'm doing the both cross multiplying. I didn't in the first question, the blue one, because I wanted to get L by itself. But here, I have to because k is on the bottom of the fraction. So to get k by itself, I need to divide it out by sine 32. Okay, all into our calculators at one time, and we get 69.6. One thing I want to point out, because it's kind of hard to, am I on the right track? Do I have the right answers? A little rule for you. The biggest angle should always be across from the biggest side. So side K, we got 69.6. It's the biggest side of them all. It should be across from the biggest angle. And 120.9 is definitely the biggest angle. So it gives us a hint if we're on the right track. Small side, smallest angle. Biggest side, biggest angle. Okay, those are basically the two problems. This page right here. The blue one is finding a missing angle. The green one's finding a missing side. That's all we can really do with the sine law. So those would probably be good things to have on a learning goals sheet. Let's try a little application. Because as we know, the picture is usually the hard part. So we have a wall. It's 1.4 meters tall, and it started to lean. And now makes an angle of 80 degrees with the ground. So if this is my wall over here, it's 1.4 meters tall, and it makes an 80 with the ground. Now it's a little hard to see, so I'm going to draw it over here. So I got 1.4 meters tall and makes 80 with the ground. A 2-meter board. So you see the board right here. It's 2 meters. Okay. It's jammed between the top of the wall and the ground. Okay. It's 2 meters. To prop the wall up, assume that the ground is level. Okay. At what angle does the board make with the ground? Obviously the angle down here. That's something we can solve using our new idea of the sine law. I can because I have two things that match up. I know that 80 is across from 2. So sine 80 goes with 2. And I know that x goes with 1.4. So the sine of x is 1.4. And I can solve this by cross multiplying. So let's do that. And this is going to be one of those kind of tricky ones because I want to get sine, I want to get x by itself. So if I bring the 1.4 up, sorry about that, we get 1.4 sine 80. I'm going to leave the 2 where it is because I kind of want to get x by itself. To find x, we're going to do the inverse of whatever 1.4 sine 80 all divided by 2 happens to be. And I got 43.6. Okay. Let's look at part B. How far is the base of the board from the base of the wall? So the board hits, there's the base of the board, there's the base of the wall. That's what I want to find. Well, to find that, I kind of need to know the angle at the top, which we can get because we know triangles add up to 180. We figured this bottom corner was 43.6. If I take 180 and I subtract the other two angles, we're left with an angle at the top of 56.4. So this is problem number 2 of the sine law, finding a missing side. So let's match up the ones we already know. The 80 goes with the 2. The one I want, 56.4, is going to match up with y. And then we're cross multiplying and solving again. And we spent all that time on cross multiplying at the beginning of the course. We're going to use it over and over and over again. And divide out by sine 80. And if you do that right, I got 1.69 meters. And if you can do this application, you basically can do the sine law. It's only 2 questions we can really do. Okay, but again, it's about drawing that diagram. That's going to be our tricky part. Last one. A bridge across the valley is 150 meters in length. The valley walls make angles of 1654 with the bridge that spans it. How deep is the valley? And we've seen questions like this before, except for I usually told you how deep the valley was and asked you to find the bridge. So now we're going to work backwards. So let's take our diagram here. Right, there's my bridge. It's 150 meters long. And my valley is deep. It's way down here. I want to know how deep it is. It kind of looks like right angle triangles are happening here. And it's true, they are. Those are right angle triangles. That's great. Except I can't divide the 150 into 2 equal parts. These 2 things are not equal. And they're not equal because the angles, 60 and 54, are not equal. If they were, if those were equal angles, you could divide it in half and you'd be good to go, SOHCAHTOA. But because they're not, I can't treat this as 2 right triangles. I'm just going to redraw it to make it a little bit bigger, easier to see. Okay, so I got 60, I got 54, I've got 150. It goes all the way across and cannot be split in half. I want to know how deep the valley is. I want to know how the height of that, if you will. So to figure this out, I know there's right triangles in here, but I can't use 75 and 75 at the top. However, if I could figure out this side or this side, I could then use a right triangle and do SOHCAHTOA, because I would have an angle, a hypotenuse, and an opposite. That would totally work for me. So my objective is to find x. You could also do this where you're finding y. That would totally work also. Nothing wrong with doing that. It's just the other half of the question. How can I find x is the question. Let's go back for a second. Let's get rid of this right triangle idea and just call this side x. Well, doesn't this look like a non-right triangle now? And can't we possibly find the angle in the bottom? Because we know triangles add up to 180. This angle down here has to be 66. And we know that's across from the 150. So there's a sine law question. Sine 66 goes with 150. Sine 60 goes with x. So do our little cross multiplying. We'll get x sine 66 equals 150 sine 60. We want to get x by itself and divide out 150 sine 60 by sine 66. It's one of our 2 basic problems. And we should get 142.197. Okay, now if we look at our diagram again, think about our diagram, what is that? Well, that is this side over here, 142. 0.97. This angle we know is 54. The height of my valley, the depth of my valley is right there, h. Well, that's a right angle triangle now. I can use SOHCAHTOA again. So I can have the opposite. I have the hypotenuse. SOHCAHTOA, O and H is sine. So the sine of 54 equals h over 142.97. I can solve that by cross multiplying. 1 times h, 142.97 times the sine of 54. And I got 115.04 meters. Hopefully you did too. Now, when I put the notes together, I actually did the other version. So you have both options now. I showed you how to do it using the 60 side. So I found y. But as you can see, it comes out to the same answer either way. The big idea here is sometimes we can combine trigonometric ideas. Sine law for the non-right part, SOHCAHTOA for the right part. What I want you to take out of this today, being able to do the sine law, the two basic questions, finding a missing angle, finding a missing side. That's kind of the key there. So try some of the homework questions. If you're stuck, come see me.